there are so many forces out there. So mainly we are going to concentrate on one important force that we will see today. So let me go with the nature of forces and what are the forces there in our nature. So mainly we have divided force into two major parts. That is what one is contact force. One is contact force, another is non-contact force. Okay, contact and non-contact force. Okay, we already know the contact force. We have already discussed. Contact force is what? It is the force which exists only when there is contact between two bodies. Okay, so when you want to slap someone else, you have to touch or you have to contact with that person. Then only the force will be applicable there. Otherwise, it will not. So similarly, the non-contact forces, what will happen? They exist whether bodies are contact or they do not contact. So then also it will exist. That is what like a gravitational force. Apple is not in contact with the Earth surface. Then also the gravitational force of Earth acting on the apple. Okay, so those kind of forces are called as non-contact force. So mainly in this we study about the normal force, which you have already studied. Normal force and tension force, this also you have already studied. Tension force, and one more is frictional force. Okay, so frictional force, or simply we can say friction force. Okay, so now about non-contact forces. In non-contact forces, as you know, very important is gravitational, very familiar to us. Gravitational force, and what is your magnetic force? Magnetic force. Similarly, electrostatic force. Electrostatic force. Okay. So many more. So these are what the non-contact forces, and here contact forces. This you already know about normal force, which will act on the body when body touches the surface. When this body kept on this one, so this mass will come here. That is what we call weight. Equal and opposite force act normally. That we call it as what? Normal force. Okay. So bodies are in touch. So similarly, tension is what? When you if this is a string, when you pull the string away both sides, what will happen? Some tension developed inside. So that is what the tension force. It will act only when you touch that string and you will pull it. Okay. So similarly, one more force, that is what the frictional force. Again, very important. So these two we have already discussed, normal force and tension force. We have solved problems also on that one. So today we are going to concentrate on frictional force, or what exactly friction is. Okay. So this is what the topic of discussion in this class. What exactly the friction is. Okay. So you may be observed there is when you start moving, if suppose you start moving in the sand, there is some opposition. You cannot walk easily. Okay. So there is something which is opposing the motion. Okay. So similarly, what happens if I take an example of the an object. So suppose this is what horizontal surface, and this is an object. Okay, so I have connected object over here. Now I want to apply some force. If I want to apply some force here, so what I can do? If I want to apply the force on here, instead of pushing it, so I will apply force on this one, because if I push it a little also it will move. But usually when we apply the small amount of force, objects will not move. Okay. Suppose if I put some mass over here, you are putting some mass, but it will not it will not move over there. Or if I put it this way, obviously for this much it should move. Let me check what will happen. So even if I put this much of mass, then also body is not moving. That means large amount of force I am applying. Suppose some 500 ml of mass is there, or means half kg. So some half liter. So if that is so, it should move, but it is not moving. So what's stopping this? Okay. If I apply more force, then what will happen? It may move for for some distance. But for that much force, why it is not moving? What make it to stop? So that is what today's discussion. What exactly is stopping it? That stopping force is nothing but what your frictional force. Okay. So we will look at what exactly the frictional force is. So what exactly is stopping that body? So there are two surfaces. So when outside the surface look like very plain. So you kept on an object on that one. Okay. But actual scenario is not like that. So what will happen? Surface is not the plane horizontal. Surface may be like this. Okay. If when you observe it microscopically, the surface is like this. So similarly, this surface also having it is also having some rough surface over here. This body. So what has happened? There is an interlock. There is an interlock between the surfaces. So if surface is plane, if you apply some F amount of force, what will happen? Body should move. It should accelerate. But it is not happening because of this interlocking between the surfaces. Okay. So now what will happen? If you apply some force F, the body will not move suddenly. Why? Because of this interlocking. So it is interlocking. It is not moving means according to what your Newton's law, what we think. There may be some opposing force. But why that opposing force is coming? Because of this interlocking. So that opposing force is what? It is nothing but friction. Okay. So what exactly friction is? It is a exist or it comes in action when two bodies are in contact, and this is stopping the motion, relative motion of these two. When you apply force, it should move, but it is not moving. Which is stopping? This frictional force is stopping. Okay. It is always act tangential to the surface, and it opposes the relative motion of the object. So how we can define the friction? It is the contact force which opposes the relative motion between the object and acts tangentially to the surface. Okay. So what I can write is a contact force. A contact force which opposes the relative motion. Okay, so which opposes the relative motion between objects and acts horizontally or tangentially along the horizontal surface, or acts tangentially along the surface. Okay, act tangentially. What we can write along the surface, or act tangentially horizontal surface, along the horizontal surface. Okay, so this definition what may bring some new words, but you can simply say it is the opposing force which opposes the relative motion between the object. But you have to give direction also. It is always acting tangentially to the horizontal surface, or it is tangentially to the surface to which it is in contact with it. It doesn't mean that always horizontal. It may be vertical also, but it all depends on it. It all depends on its moment. Okay. So this is what happening over here. So this force we call it as the friction force or frictional force. Okay. So now, if you look at the this action of friction force, it may come in both cases. When body is at rest, when you apply some force, it will not move. Motion you cannot observe. That means what? That means there is some opposition force. Suppose body is moving. If you do not apply force, what will happen? After some distance, it will come to rest. Why it is coming to rest? According to Newton's law, there should be some opposition should be there. Unless opposing force acts, it will not come to rest. it is coming to rest means there may be some opposing force. So that opposing force is also what? That is also friction. Okay. This is coming when body was at rest. This is coming when body is in motion. Okay. So that is why we classify friction into two major parts. That is what we call it as the one is static friction, and another is kinetic friction. Okay. So what is static friction? Static friction is when body is at rest. Kinetic friction is when body is moving. But actual meaning of that is not like which acts when object is at rest. No, it is not like that. So that will go in detail what exactly static friction and what exactly kinetic friction. So as of now, so what friction is a contact force which opposes the relative motion between the object and acts tangentially along the horizontal surface. And there are two major branches of or types of this friction. That is one is static friction, another is kinetic friction. Okay. So we will discuss about the static friction. Okay. So what exactly what do we mean by the static friction? Okay, as we already know. So there is an interlocking when body is here, when it is very smooth. If you apply the force, body should start moving. Okay. When you apply little amount of force, if you apply a very small force here, it starts moving. But usually what happens? It will not move. It will be remain at rest. Even though you are applying the force, that is very important. If you are not applying force, no need to worry. Remember, when no force, no friction. Okay. When you apply little force, what will happen? Because of this interlocking, it will oppose the applied force. So this opposition is what is? It is nothing but frictional force. Because of this opposition, body is not moving. Net force becoming zero. When net force becoming zero, body will not move. So if body is not moving, means it remains at rest. Now what will happen? You will increase some force. You will make it to 2F. Even though you apply 2F, what is happening? Body remains at rest only. That means the frictional force will also increase as you increase the applied force. So this will also become 2F up to some value. Okay. After when you apply large force, obviously it will move. So because of this opposing force, body remains at rest. So this opposing force is what? This is nothing but frictional force. Okay. This is nothing but frictional force or force of friction. Okay. So this force of friction which keeps body remains at rest, that we call it as what? Static friction. That doesn't mean that when body is at rest, at that time friction is coming. No, when body is at rest, no force is applying means no friction. It is clear. No applied force, no friction. When you apply the force, then what will happen? Then the static or frictional force will develop. Okay. So why it will develop? It to keep body remains at rest. Okay. So that kind of frictional force we call it as what? Static friction. So how we can define the force of friction? The force of friction which comes in action. This is very important. Which comes in action when external force is applied. External force is applied and keeps body or object remains at rest. Okay. The force of friction which comes in action when we apply the external force, and what it will do? It keeps the body remains at rest. It will not allow body to move. So that kind of friction is called as what? It is the static friction. It is not allowing it is not allowing body to move. Okay. So on what factors this friction is depending on? When it is more or when it is less. Now what will happen? Suppose if I take an object over here, suppose this is an object, so it was placed on an horizontal surface. So here interlocking is there throughout the surface. If I change the size of body but same mass, if I increase the surface area, okay, if I increase the surface area, so what will happen? We will think that the interlocking will increases. So what we think? We will think that the frictional force will also increase. So static friction depends on the area, but remember, static friction is independent of the surface area or area of contact. Better to write area of contact. Usually we will think it depends on area of contact, but it will not depend on the area of contact. But then how we can measure this one? On what factors it will depend? It mainly depends on, you can see if there is a small object, if you apply a little force it will not move, but if you little increase the force it will start moving. Okay, so frictional force is less. Instead of that, if you take a large object, you apply some force, but if you increase the force little, it will not move. You have to increase the force by large amount, then only it will move. That means here frictional force is less, here frictional force is more. That means it maybe depends on some properties of matter. So what is that property of matter? That is nothing but normal reaction. If mass is more, normal reaction is more. If mass is less, normal reaction is less. Okay, so that is why the frictional force or static friction depends on what? Depends on normal reaction. Okay, so one more thing, the static friction we will denote it by what? S stands for what? F stands for static friction. Okay, so here now your static friction is proportional to what? Normal reaction. It depends only on the normal reaction and nature of the bodies. Nature of the body in the sense what type of body it is, whether it is very smooth or whether it is very rough, it depends on that one. Okay, so to remove this what is proportionality, we can write it as mu s into n. Here it is very important. What this mu s? Mu s is coefficient of static friction. Coefficient of static friction. Okay, so that is why S is coming here. Okay, so what is this coefficient of static friction? It depends on the object. It is different for different object. If you take smooth steel object, then this coefficient is very less. So if this is less, obviously static friction is going to less. So it can easily slide. Instead of that one, if you take some rough surface, if you take the wood, the coefficient is more for that wood. Okay, that is calculated by means of something else. So that is not required now. So if that is more, friction is going to be more. That is why it is very difficult to move the rough surfaces or wooden or something. More force is required to move that one because friction, static friction is more. Instead of that one, if you take the bodies whose surfaces are very smooth, like steel or something, if you apply little force, it will move. So because its coefficient is less, so that is why it depends on this coefficient depends on what nature of the body, what type of body it is. Okay, so n is going to be what it is, the normal reaction. Okay, so normal reaction usually what? M into Z. So that means normal reaction depends on what? It depends on the mass. So as we know, suppose there is an object, say if you apply say some 1 Newton of force, body will not move because of frictional force. What is frictional force now? That is also 1 Newton. When you make applied force 2 Newton, body will not move because this static friction is also increasing, so it will also become 2 Newton. Okay, as you make it 3 Newton applied force, obviously it has to stop, means so static friction also increases by 3 Newton. Okay, so that means the static friction or frictional force is increasing as applied force is increasing. That means it is adjusting itself. What is its aim? Its aim is to keep body at rest. For that it is adjusting itself. So that is why the frictional force is also called as self-adjusting force. Self-adjusting force. Okay. So because of this property of self-adjustment, it will keep body at rest. But if you cross the limit, when you apply say 2 Newton, body will not move. and you apply say 4 Newton, body will not move. Rest. When you apply say some 5 Newton, body just start moving. Okay. Remember, if you apply 4.9, it will not move. If you apply 5 Newton, it will just start moving. That is what. Okay. Just start moving I am mentioning. So this value of force when body just start moving, that is what we call it as limiting force of friction. Limiting force of friction. Okay. So what is the limiting value of friction or limiting force of friction? It is the external applied force, or it is the static frictional force which opposes the motion of the object before just body start to move. Okay. Or it is the force of friction or static frictional force. Static frictional force developed just body start to move or start sliding on another object, on another surface, or you can call it as object. Okay. So the static frictional force developed just body starts sliding on another surface. So, or it is the maximum value of the static friction just before the body to start moving. If you little increase beyond this force, the body start moving. If you little decrease, it will not move. So that is why it is called as what limiting force of friction. Okay. So is called limiting force of friction. Limiting force of friction. Okay. So this is what we call it as the limiting force of friction. So we are discussing about the limiting force of friction. Limiting force of friction. So what it is? Limiting force of friction. It is the maximum value of force of friction which comes in action, or which comes in action just before body start sliding. Okay, so you can rearrange or you can reframe the definitions according to your convenience. So there are laws of limiting friction. There are some points we call it them as laws, but they are just points. What is the direction of this limiting friction? It is the direction of limiting friction. Direction of limiting friction is opposite to what? If there is a body, so friction will be in this direction. This is what applied force. Okay. So the direction of limiting friction is opposite to applied force or external force. It is opposite to applied force or external force. Okay. And it is along the tangential direction, or along the tangential group. It is tangential along. It is tangential along horizontal surface. Okay, horizontal surface, along horizontal surface. Okay. So next you can say it depends on. It is directly proportional to. It is directly proportional to normal reaction. Okay. So it is directly proportional to normal reaction. That means what? This limiting value of friction. Limiting value of friction is proportional to normal reaction. That means it is it is again what? It is nothing but static friction only. It is again what? Mu s into n. So this limiting value means it is maximum value of friction. Limiting value is nothing but what? Maximum value of static friction. So this is equals to mu s into n. So from this one thing we can conclude that your normal static friction is always less than or equal to mu s into n, or your static friction is always less than or equal to limiting value, because it is a maximum static friction. So always static friction is less than maximum or equal to maximum. So that is why it is always less than or equal to mu s into n. Okay, this important property we can get from this one. Okay, so from this again we can conclude that it depends on nature of body. Okay, so nature of body or object sliding, and you can write one more thing, that is it does not depends on it is independent of what is that? The area of contact, whatever may be the area, so it is independent of that one. So these all 5 are called as what they are called as the laws of limiting force of friction. Okay, laws of limiting force of friction. Okay, but only important thing result what we get here we can get from this one. Okay, so suppose you can say if force is applied force is less than friction, so body will be at rest. If it is equals to the maximum friction, so then also body is at rest, but it will just start moving. Okay, if applied force is more than frictional force, F is more than frictional force, so obviously what will happen? Body will move. Okay, still here what is this? This is nothing but all about static friction. So when body start moving, then also friction comes in action. That is what we call it as kinetic friction. So about static friction and kinetic friction, so many things we have to discuss. So we will discuss in next class.